In previous sections within this unit, we've talked about actual angle measurements and side measurements within triangles and finding them and working with different types of triangles and manipulating equations so that we can actually find the exact measurements. But in this section, we're not going to look for exact measurements. We're just going to compare some measurements and what's bigger, what's smaller, what's the in-between. So we're going to do this within one triangle, and then we'll follow up and do this within two separate triangles. You're going to have 4 index cards. They are all going to say the same thing on the front. And the reason is just because there's a couple different relationships that you need to know between angles and sides within triangles and how they relate to one another. So there isn't really any specific name or anything like that, but we do need to actually have these things memorized. So the very first one is if one angle is larger than another. So let's look at, for example, at angle Y, which is 65 degrees, and then we'll look at angle P, which is 40 degrees. So if one is larger than the other, then the side opposite that angle, so opposite that angle would mean across from, so this is the side opposite, is larger or longer than the side opposite the other. So this right here. So in symbols, what I would do is I would say that since the measure of angle Y is greater than the measure of angle P, so that would mean that PT is going to be greater than TY. Okay, and actually that shouldn't have the thing on it. Sorry about that. Let me get rid of that real quick. Well, I'll just rewrite it. All right, so all I did was just take the side across from angle Y and say that it's larger than the one across from angle P. And it's a pretty simple concept. It makes perfect sense. If the angle is larger, that means it's opening up further, which means the ends of the angle are further apart from one another. The next one that we have is the opposite. So if one side is longer than another, then the angle opposite that side is larger than the angle opposite the other. So if we're looking at, for example, the 12, and let's go ahead and with the 10, okay? So this side is across from this angle, and this side is across from this angle. So what we have here is that TY is less than, so TY is 10, and that is less than 12, your PY. So what that means then is the measure of angle P is going to be less than the measure of angle T. And you don't have to put it in this exact order. You could flip it and do PY is greater than TY. It doesn't make a bit of a difference. You're just comparing them and saying how the measurements work. So, this could potentially be 75 degrees and this one would be 55. We don't know the exact measurement, but we can at least kind of get an idea of, what measurements could go in there and how they relate to one another. So the next thing we have is that the longest side is opposite the largest angle, and then vice versa, the largest angle is opposite the longest side. So those two go hand in hand, and then we have the exact opposite, where the shortest side is opposite the smallest angle, and the smallest angle is opposite the shortest side. So we're going to work with this information and put these in order from largest to smallest, smallest to largest, compare the two, and see how these things work. So here's the first example. We're going to order the sides from longest to shortest. So what I'm going to do is just go through my angles, this being the 25-degree angle. It is across from this side. And since this angle is the smallest angle, that means this side will be the smallest side. Okay, then I'm going to move on to this one, 75, and this is across from this side here, right? And then our 80-degree angle is across from this side over here. So 80 is the largest, which means this one would be the longest side, so long. So then what would that mean about this side over here? Well, that would then mean that that one's your in between, so we'll call it our medium side. So if we're going longest to shortest, what we can do then is list them in that order. So longest would be BC. After BC, we go to our medium side, AC. and then we go to our smallest side, which would be AB. And one thing that you'll notice too is if I were to order the angles from largest to smallest, so I do angle A, and then I do angle B, and then I do angle C. If you notice these three letters, A is across from BC, B is across from AC, C is across from AB. So you'll notice that the angle is not used within the letters that you use to name the side. And that can kind of help you keep things organized, at least when you just have one triangle to work with. So number 2, order the sides from longest to shortest again, but we only have 2 out of 3 angles. So how do we find this angle right here? Because we can't just assume it's some kind of measurement. We can't just ignore it. And so what do we do? Well, in previous sections of this unit, we know that there are 180 degrees in a triangle. So if we take our 45 and we add to that our 56, we get a total of 101. So these two angles down here add up to 101 degrees. So if those add up to 101 degrees and there's 180 total, we could subtract that from our 180, giving us 79, right? So that would mean this angle here is a 79-degree angle. And now because of that, we actually know that since this is the biggest angle, then this side right across from it is going to be the longest side, right? So then if we keep working our way through, 45 is the smallest angle, and that is across from this side right here. So this is going to be the smallest side. And then our third angle, our in-between, is going right there. I should probably dot that so you know it's not part of the triangle. And this one would be our medium, our in-between. So if we're doing longest to shortest, our longest side would be WY. Our in-between would be WX, and then our last one is XY. Okay? All right, so our next example, order the angles from smallest to largest. Well, this one works exactly the same way as the sides or as the angles that we were working with in the last examples. So the smallest side right here is going to be across from the smallest angle. So this is your smallest angle. All right, and then your longest side being the 7.1, this one is across from your largest angle. And that would make this one your in-between, and that would make this one your medium angle, your in-between. So if we're going from smallest, this time we're starting with the smallest angle, we're going to say angle Q comes first, and then from angle Q we're going to go to angle R, and then we're going to go to angle P, and that would be smallest to largest. All right, so now we're going to work within 2 triangles and comparing 2 different segments within these triangles. So you see triangle ABM over here and BMK over here. And these are not congruent triangles. You know, if we wanted to, we could take 40 and add 30 to it, which is 70. We can take 180 and subtract 70, which gives us 110. So this angle right here is 110 degrees. These two right here are supplementary. So if we take 180 and subtract 110, we get 70. So this is a 70-degree angle here. And then if we add these together, 70 plus 60 gives us 130, and take 180 and subtract 130 from it, we get 50 degrees. And so you'll notice that these angle measurements don't match up, right? So if they don't match up, then we can't really talk about, side lengths being congruent. So when we say compare, what we're looking for is which one's bigger, which one's smaller. Just write a statement to say how they relate. So we're looking at AB, which is right here, with BK, which is over here. So this side, AB, is across from a 110-degree angle, right? Whereas this one is across from a 70-degree angle. So what that would mean then is that our AB is going to be greater than BK. Or if you wrote it the other direction, you could write that BK is less than AB. B, which is also the same thing. It's like saying I'm older than you or you're younger than me. It's the same information, just given in opposite order. All right, and then our last example, so same type of information. We have two different triangles that we're comparing, but this time we're going to compare angle measurements. So angle CDF, so CDF would be this angle here, and then the measure of angle EDF, so EDF would be this angle measurement here. Okay, so this angle is across from this side, which is 12, right? And then this angle is across from this side, which is 13. So since CDF is across from a smaller side, it's going to be the smaller angle. So the measure of angle CDF is going to be less than the measure of angle EDF. Or writing it backwards, the measure of angle EDF is going to be greater than the measure of angle CDF. And again, it's all based on the fact that this side is larger than that side right there. Okay? And that's really it. You know, as long as you can find a bigger number and a smaller number, as long as you know there's 180 degrees in a triangle, you know that these two are a linear pair. Remember, we keep coming back to those vocab words. Linear pair meaning they are supplementary. Supplementary means they have a sum of 180 degrees. So, you know, working with all this information is kind of all coming full circle at this point and working together. And as long as you can get all that information filled in, this really is not very hard at all. Maybe just a matter of making sure that you read the directions correctly, but make sure you have it written down. Come in with any questions that you may have, and I'll see you soon.